Okay. Good morning, students. So I'm going to start this today's study about the average energy of the Planck's oscillator. Okay. Planck has taken the black body to be so imagine that there are number of oscillator like this. Okay. With an energy E is equal to H into nu. Okay. E is, there are, Planck assumed that the black body radiations are not traveling in a continuous sinusoidal form, but they are traveling in the form of a discrete small packets of energy, which he assumed as E is equal to H into nu. Okay. E is related to the frequency, but with the constant value of H, which is a Planck's constant, okay, which is named after him later on. Okay. So these are all, so imagine that this is a cubical black body vessel where the black bodies are radiated, but they are all now in the form of small discrete units. Discrete means a broken, okay, units, small separate units, and all of them are oscillating with a particular energy. Okay. So since there are many number of oscillators or resonators, I can say, okay, we need to calculate, say this may be having an, let us assume this oscillator to be N1, this may be N2, this may be N3, this may be N4, N5, N6, and so on up to N to the suffix N. Okay. And imagine that there may be, it may have a particular energy of, okay, E1, E2, E3, E4, and so on like this. Okay, each will have an energy. Some may not have energy also. So assume it as N suffix naught. Okay, and it may not have energy also. Okay, it may start off, but it can end also dead, isn't it? The oscillation may not proceed. Okay, each single unit is supposed to vibrate. Okay, like a simple harmonic wave motion. Okay, but all of them are resonating when there is an energy given to them in the form of heat. Okay, all the oscillators, each one is a discrete oscillator oscillating with a particular vibration. So since there are n number of such units here, we need to calculate the average energy of the oscillator in a black body system, which can be taken by this formula. This is the average energy, which is given by epsilon is equal to E by total N. Okay, E refers to the average energy of all the oscillator. You have to add the average energy and divided by the total number of oscillator. Okay, so we are going to proceed with this. E is the average energy of the oscillator, N being the number of resonators. Okay, with this idea, we'll have to first calculate the number of resonators. There are two parts. You need to calculate what is E, you need to calculate what is N, and then substitute back in this formula. You will get the value of the energy of the average energy of the Planck's oscillator. Okay. Now, first part of our calculation is N. Okay. So you can put it as light and also audio. Okay, so we need to calculate the number of resonator. Okay, so there are two parts. As I said in this formula, you can put it as equation number 1. We are going to calculate the denominator. Okay, the denominator portion is the number of resonators. So calculation of the number of resonators. N is a number. Okay. So N can be, as I said in the previous this one introductory class, N can be N1, N2, N3, N4, and N5, and so on. Okay, it can, suppose there may be some N value which may have some zero energy also. Okay, but let's start with that. Okay, let N naught. Okay, let N naught be the energy. Oh no, sorry, not energy. The number of resonator. Okay, let N naught be the number of resonator having energy, having an energy value 0. See, if you have 100 children and ask them to play, some 10 children may be running, some 10 children may be, they wanted to talk with their friends. Some 10 children say, no, I don't want to play. I want to sit. Okay. I'm tired. I'm not going to play. Some 10 or 20 may run here and there. Okay. Like this. It's like it's a children's group, isn't it? Same way in a black body cavity also, some of the resonator may not resonate. Some may be resonating with a high energy, some may be resonating with a low energy, and it goes on. Okay, so let's assume N naught, N suffix 0. Okay, here be the number of resonator having an energy value equal to 0. That means imagine a case that they are like small children who are not willing to play, they want to rest. Okay, so that also has to be taken into account in a cavity. Okay, because they are also inside the black body cavity. We cannot remove them. Okay, into our calculation we are going to say, but we are going to say, yes, among the 100 children, 10 are not playing, 0. Their energy is not wasted, but it's there. Okay, they are sitting. Okay, sitting is also some work. Okay, but some are going with some energy. So maybe 9 students are running here with some energy. Yeah. And another, suppose 8 children are running up to this place with some energy. Okay, and suppose you may say that there may be 20 children who are running 100 kilometer or this, I mean, maybe 10 or 2 kilometers up and down, they're running. Okay, they're going for a marathon race. All these things are possible, isn't it? So you need to calculate, maybe 11 children having this, they are going for 1 kilometer running, and you may say that, okay, 100 meters some are going, and another may say maybe 1.5, this one their meter they are running, like this. Okay, so all these things have to be taken, nothing can be deleted or removed. Okay, so N naught is the number of resonator having the energy value 0. Similarly, okay, so this can be given as N naught. Okay, in a mathematical form, this can be given as N is equal to, okay, sorry, one less, N naught is equal to N naught e to the power of, okay, actually it is E is raised to the power of epsilon by K. Here is a major change. Okay, Planck assumed that the energy is in the form of exponential E divided by KT, whereas in Planck's he directly multiplied with KT. In the Rayleigh and Jeans formula, we have found that the energy is equal to K into T. Directly, it was assumed that the temperature was taken multiplied with the Boltzmann constant. But here, Planck assumed that the energy is varying exponentially. Okay, divided by the Boltzmann constant into T. It is an exponential variation. This was a major breakthrough in the quantum hypothesis. Okay, whereas Rayleigh and Jean, they took energy as directly KT, but here Planck assumed that it is varying in the exponential form of E divided by KT. This is very, very important. Try to understand this point. Okay, so here, since the energy of this oscillator is 0 as we assumed it here, okay, I'm going to put it as 0 by KT. Okay, now let's, here epsilon is equal to, since epsilon is equal to 0. Okay, now similarly, the number of resonators having the energy of epsilon. Okay, assume that these are children who are sitting idly. Okay, assume that there are some 11 or 12 children who are playing for, who are running up to 100 meters. Okay, so let that be the number of resonator. The number of resonators having an energy N1. Okay, so what the teacher will do, okay, all those who are interested to go for 100 meters, come together and we can go for a race. Okay, so the teacher is calling and number of children are coming, maybe 12 or 13 are coming. Okay, so all those category are put it as N1. Okay, but they will have the energy of the children who are sitting. Okay, it is N into N Okay, n is also some energy. Okay, so n naught is also some number of children. So they're sitting, so their energy is taken and then it is taken. Okay, so it is n naught e to the power of n naught into e to the power of. Okay, sorry, here it is minus epsilon by kt. Okay, so let's assume this as equation. One more equation, and similarly n2 is equal to n naught e to the power of, okay, minus 2 epsilon by kt, and it goes on, okay, with up to n4 again. It goes on similarly like this. I don't know whether you're able to see the board. N1, N2, N3 will go, N3 will become N naught e to the power of minus 3e, okay, and N4 will become N naught e to the power of minus so and so values. Okay, so similarly I can generalize it as, similarly I can put it as nr, okay, is equal to nr, okay, e to the power of minus r epsilon by kt, because it's an exponential term. Okay, it will be coming like this. Okay, now what is our main aim here? Where did we start? We are starting to find the average energy, but average energy epsilon is equal to E by N, and in which we are trying to find the number of resonators. Okay, so the total number of resonators inside will be, okay, will be the addition of N1, N0, N1, N2, N3, it will go on. Okay, the total, so the total number of resonators, okay, capital N is equal to, okay, it will be N0 plus N1 plus N2 plus N3 and so on up to NR. Now substitute these values into this above equation. Okay. N0 will be, okay, in the previous equation e raised to the power of 0 will be 1, isn't it? So it will become N0 only, the previous equation. Okay, I told N0 is equal to, what is the equation? Let me tell you one more time. N0 will be, N0 is what? N0 e to the power of minus epsilon by kt, okay, and epsilon value will become 0. So this factor will become 1, N0 will become N0 only. Okay, so I put N0 as N0. Okay, now the next one, but N1 has some value as N0 e to the power of minus 1 epsilon by kt, or just epsilon by kt. Okay, and N2 will become N0 e to the power of minus 2 epsilon by kt. Okay, and this will become N0 e to the power of minus 3 epsilon, no, sorry, 3 epsilon by kt, and so on up to, okay, so on up to, it will become, okay, last term will become N0 e to the power of, instead of 3 or 4 or the numbers, I will put it as r epsilon by minus r epsilon by kt. Okay, you will find that N0 again is common in all the terms. So take that N0 outside. So N0 will become 1 plus e to the power of minus epsilon by kt plus e to the power of, okay, minus 2 epsilon, sorry, 2 epsilon by kt plus e to the power of minus 3 epsilon by kt and so on up to e to the power of minus r epsilon by kt. Okay, let's assume e to the power of epsilon, e to the power of minus epsilon, e to the power of minus epsilon is common in everyone, everywhere now in this equation. So let's assume that, okay, let us take, okay, e to the power of minus epsilon by kt as is equal to a particular term called y. Okay, to make this mathematical equation a simplified one, we are going to assume this way. Okay, so this equation now will become, okay, this is n is equal to n naught. Okay, so therefore the equation will become n is equal to n naught 1 plus e to the power of, shall I put it as e to the power of, the entire thing is now y, right? Okay, the entire thing will become e to the power of minus epsilon by kt will become y. So it will become 1 plus y plus, okay, this will become y to the power of 2 is there already. No? So it will become y2 into this entire thing will become y, but there is 2. So it will become y square. Okay. And then this will become y to the power of q. Okay. Y to the power of 4 and up to so on up to y to the power of r. Okay. Now this equation is mathematically simplified as, okay, n is equal to n naught into this entire thing will become mathematically, okay, 1 divided by 1 minus y. Okay, mathematical equation. So n will become n naught into, okay, into 1 divided by 1 minus y. Okay, so I can put it as n is equal to n naught divided by 1 minus 1. Okay, you can give some equation number here for the number of resonators. Okay, we are going to take this equation. Okay, I'm not given a proper equation. Maybe you can give. I didn't follow, but in the notes I will try to send it. Okay, with the equation. This n is equal to n naught by 1 minus y. We are going to put back into our first equation. Remember, this equation is, isn't it? E by n naught. Okay, we have found the value of. Sorry, we have found the value of n. Okay, this is the answer for this equation. Okay, this we have put it as 1. Maybe this you can give some equation number. Probably I will give it as 2. And then we will find out, we'll have to find out the energy of the oscillator and then come back and put back into this equation. Okay, so shall we move on to the next part of the energy calculation? Okay, so this is the first half. Now let's continue and complete this one. Okay, the next part is to find the average energy. Okay, so let's move on. So the second half of this derivation is, the second part of this derivation is to find the total energy of the Planck's resonator. Okay, to find the total energy of the oscillator or resonator. Okay, both are same. So our aim is to find E. Okay, the value of E in the E which is in the numerator of the equation 1. Okay, so now the total energy of the Planck's oscillator. Okay, again, because there are many number of oscillators having different energy, the total number of the total average energy will be the sum of the energy of the individual oscillators. Okay, so let's assume that, okay, so it is the I can say this the total energy will be equal to the sum of the, okay, energies of all oscillators, okay, of all the oscillators, okay, resonating, okay, resonating with the energy, okay, epsilon naught, okay, epsilon 1, okay, epsilon 2, and so on up to epsilon r. Okay, so these are the energies of the oscillator. These are the oscillator having the energy with a particular numbers as n0. These are the energy of the oscillators having the numbers n2. Maybe this may be 8 children having sitting. This may be 11 children who are running up to 100 meters. Okay, this may be some children who wanted to run up to 200. Okay, 200 meters. Okay, maybe some 5, 6. Some are saying that I wanted to go for marathon race. Okay, maybe this may be some 13, 15 students. So you will take the average, maybe this may be 6. Okay, so you have to take the average energy. Okay, so how to take the average energy first? Okay, so these are the, and so on up to epsilon r, that is having the energy, the highest energy, okay, of resonators, okay, of resonators with numbers, with the numbers as n1, n0, okay, n1, n2, n3, and so on up to n, or I can say nr. Okay. With this idea, let's move on. Okay. Now, so the total energy E will be equivalent to, okay, the first one, okay, epsilon naught into n naught, okay, plus epsilon 1, okay, it is not epsilon, it is 1 into epsilon into n1, okay, 2 epsilon into n2, okay, and into, so here I will write 3 epsilon into n3 and so on up to, okay, r into epsilon into r into epsilon into, sorry, epsilon into nr. Okay. Now, since we know that this epsilon value is 0, no? Those children, like an example, those who are not having running, okay, they will have an energy of 0 value. So this factor will become 0 since epsilon is equal to 0. Okay, so I'm going to write it as, okay, so this equation will get modified as 0 into n naught plus the remaining factor will be, okay, just I can write it as epsilon n1, okay, into epsilon n2. Okay, these are all plus values here. Okay, plus it has to go up to plus. Okay, so here also it will become plus 2 epsilon into n2 up to so on. Okay, plus 3 epsilon, okay, into n3, okay, plus up to r into, okay, this last one nr is now taken in terms of n naught into e to the power of r epsilon by 80. Okay, so it goes on like this. Okay, epsilon epsilon into n. Okay, now we have to make one more substitution here. Okay, this will become 0 plus, okay, let's substitute this value here. Actually it will become r epsilon into n. Okay, now we are going to do the actual substitution in terms of, we have found n naught in the previous equation, isn't it? What is n naught? N naught will become, okay, this one first term will become 0, the second term, okay, will become n naught. Okay, n1 we have already found out as, let me write it one more time. Since we know, okay, this factor will become 0, and we know that n1, I will put that, since epsilon naught is equal to 0, that is the first factor, and we know that n1 is equal to n naught e to the power of minus epsilon by kt. This is 1 epsilon by kt, and n2 is equal to n naught into e to the power of 2 epsilon by kt, and so on up to, okay, n3 will become 3, and nr will become nr e to the power of minus re by, okay, these values we are going to substitute for n1, n2, n3, and nr. Okay, and this factor we are going to substitute as 0 because epsilon is going to be 0. This entire factor will become 0. Okay, so I'm going to write it again. This I'm going to use this n1, n2, n3 into this equations. Okay, so this will become 0 plus this factor will become epsilon, okay, into n naught e to the power of minus epsilon kt. Okay, and this factor will become so will become 3 epsilon. Okay. Plus so on up to r. Okay, we go on to r epsilon. Okay, n naught e to the power of minus r epsilon by kt. This will be our equation. Okay, now in this factor, see what you take out. This goes off. Okay, epsilon is common in all the equations, isn't it? Epsilon is common in all the equations. Same way, n naught is also common in all the equations. Take this two commonly outside. Okay, therefore this equation will get modified as, okay, so E is equal to, I'm going to take epsilon. Okay, I'm going to take n naught into epsilon commonly. N naught common in all, epsilon is common in all. Okay, take it out. You will be getting e to the power of, so this is no more. Okay, this portion only we are going to calculate. E is equal to, what are the remaining things? kt plus, okay, 2 is there, we cannot leave it 2. Okay, then we have to calculate e to the power of, again, minus epsilon by kt, right? How square is it? 2 e to the power of 2 epsilon by kt, 3 e to the power of 3 epsilon by kt, up to so on. Okay. So on to r e to the power of minus re by kt. Okay. As we assumed in the previous case, let us assume that, okay, that y is equal to minus epsilon by kt. Okay. We did this assumption in the previous case also, the same way. E to the power of epsilon by kt. E to the power of epsilon by kt is going to be assumed as y. Okay, therefore E is equal to, this will become directly e to the power of raised to the power of y. This will become 2 e to the power of, okay, e to the power of 2y, okay, e to the power of 3. I think minus also will come everywhere. Already minus is there, so no need to take here. Okay, e to the power of 4 e to the power of 4y. Okay, and so on up to r e to the power of ry. No, sorry, e will not come here, right? 2, sorry, it should be 2. I think it should be 2 y square plus 3y cube plus 4y to the power of 4 up to so on up to r y to the power of r. Okay, r y to the power of r. Okay, because this entire one will be taken. Now this equation mathematically e to the power of y into y, I think. This will become y plus 2e. Okay, this portion mathematically will become, okay, e is equal to n naught into epsilon. This entire portion, okay, is nothing but y by y divided by 1 minus y the whole square. Okay, this entire one will become y divided by 1 minus y the whole square. Okay, so I'm going to replace this entire mathematical portion as, okay, into y by 1 minus 1 whole square. Okay, take the y outside in the, as we did in the previous case, y if you take, it will become 2y, 3y square and 4y square, y cube, and goes on, it goes like an equation. And that is nothing but y into 1 minus of y the whole square. Okay. Now, this is a value for E. Okay. You can give some equation number here. Okay. Knowing this value, already n we have found out. What was the n value? We have come to the n. Okay. N value we have found it as n naught by 1 minus 1. Whereas E we have found it as n naught epsilon y divided by 1 minus y the whole square. Knowing these two values, now we are going to calculate the average energy of the Planck's oscillator. Okay. So let's come back to our first equation. What is our first equation? Okay. The average energy of the oscillator in a black body is in a black body cavity is given by, okay, I can put it as, because there are a number of, this one it is going to be E by N. Okay. Now what is E? We have calculated this. N we have already calculated from the previous equation. So I'm going to substitute this value as, okay, epsilon is equal to N naught e to the power of y by 1 minus y the whole square. N, do you remember what was the equation? It is N naught divided by 1 minus 1. Okay. 1 minus y. So remove or cancel out the equations that you can, n naught, you can cancel out. 1 minus 1, 1 minus 1 and y and 1 minus 1 in the numerator will get cancelled out. Okay. So you'll be left with epsilon is equal to, let us put it as average. So this I'm putting a bar here. Okay. So it will become epsilon into y by 1 minus 1. Okay. Here 1 and this one will get cancelled out. So you'll be left out with this equation. Okay. Now we already have assumed what is y. Y we have assumed, isn't it? So substitute that back into this equation. Since the value of y was assumed to be we have assumed y as to be what? Y is equal to e to the power of minus epsilon by kt. Okay. Now let's substitute back for this y value. Okay. So therefore, okay. So therefore our equation will become, therefore average energy will become, okay, epsilon into y value will become e to the power of minus epsilon by kt divided by 1 minus of, okay, 1 minus of e to the power of minus epsilon by kt. Okay. Okay, we have come to this equation. Okay. Now see if there is anything that we can simplify. This is also e to the power of minus epsilon by kt. This is 1 minus e to the power of epsilon kt. Okay. Now we are going to make an this one. Now take this e to the power of minus epsilon kt outside. Okay. This is equivalent to this equation as e to the power of minus x. Okay. There's a slight mathematical modification here. 1 minus e to the power of minus x can be also written as 1 divided by e to the power of x minus 1. Okay. Take this minus out. Okay. E to the power of minus x can also be taken as, okay, this can be slightly modified mathematically like this. Okay. Using this similar concept, I'm going to modify this equation. Okay. So I'm going to take it as epsilon is equal to, okay, keep this epsilon as such. Okay. This will become, okay, just epsilon, this will become 1. This entire portion will become 1 into epsilon. So I'm going to put it as, okay, 1 divided by e to the power of x. Okay. So assume that this is going to be x. Okay. This factor, if you can assume it as x, it will become e to the power of x. Now in the previous equation I said, isn't it? Keep this in mind, e to the power of minus x divided by 1 e to the power of raised to the power of minus x will become 1 divided by e to the power of minus x minus 1. Okay. You see, assuming this way, we are going to modify this equation. Okay. So this will become this epsilon is already there. Okay. This part. Okay. We are going to put this as x. Okay. This is e to the power of minus x. This is 1 minus of e to the power of minus x. Assume this factor to be x. Okay. Minus epsilon by kt. Let us assume it as x. Okay. Then you will get it this way. And this is mathematically equal to 1 divided by e to the power of x, e to the power of x minus 1. Okay. So with this similar idea, I'm going to modify this equation. So epsilon is unchanged. Keep that on this side. This factor is going to be modified as e to the power of minus x minus 1. Okay. E to the power of our x is going to be nothing but, okay, this is going to be epsilon by epsilon. Okay. Minus. Okay. So this will be our final equation. Okay. Or I can write it as directly simply as epsilon divided by e to the power of epsilon by kt minus 1. Okay. So this is our final Planck's equation. Okay. So according to this equation, so I'm going to write this equation on the top. Okay. This factor is going to be x. So this will become minus x. Okay. Just epsilon by kt, you take it as x. Then you will get this value. Okay. Now, so this is our final equation of average energy of the Planck's oscillator is equal to epsilon by e to the power of epsilon by kt minus 1. Okay. Now, what are the things that we can learn from this equation? Okay. Now, after knowing this average energy, we need to calculate the energy density. Okay. This is the average energy of the Planck's oscillator. Okay. Very important. Okay. This is average energy of the Planck's oscillator. Knowing this value, okay, I'll just try to continue another 2 sentences in another 5 minutes, and then I will complete it. Okay, we need to calculate it's showing as internet unstable. Okay, now we need to calculate the energy density. Okay, I will just complete this portion. Okay, we need to calculate the energy density. This is the calculation part. The energy density of the Planck's oscillator. Okay, in the frequency range. In the frequency range of nu and nu plus d nu. Okay, is given by, okay, this is nothing but the average